This is my grandma, Jan Chang. She's an amazing cook, but often struggles with the smallest things like opening a jar or buttoning her shirt. And this is because, ever since I remember, Grandma Jan has struggled with arthritis in her hands. And seeing the frustration in Grandma Jan's eyes as she tried to accomplish everyday tasks stuck with me. It made me wonder if I could use my passion for computer science to help her and others like her better manage and track their arthritis. And that question led to the idea for my project, Arthritrack, an app designed to track arthritis symptoms, provide real-time feedback, and recommend exercises tailored to each person's hands and build a community for those who struggle with arthritis. Hi, my name is Abigail Nguyen. I'm from Bloomfield Hills, Michigan, and I've been working on this project with my mentor Jamie through Polygence since June. And today, I'll share the problem I set out to solve, what I've learned so far, and my vision for where R3 is headed. First, let's start off with a problem. Arthritis affects over 54 million adults in the US alone, and patients don't often have personalized ways to track pain or improve hand mobility. But in reality, the doctor usually gives one or two options. Either go to physical therapy a few times a week or take pain medication. And most people choose pain medication, which only masks the pain instead of improving mobility. And others may try therapy, but it often requires frequent visits that are expensive and time consuming. But my solution is ArthriTrack, an app that helps patients track pain and mobility from the comfort of your own home. It saves time, money, and makes arthritis care more accessible and comfortable. So, to build this app, I had to learn and implement three main components of mobile app development. First, we have the front end, which is designing the user interface, how everything looks on the app, and how users can interact with it via buttons and maneuvering through the app. Next, we have the backend and APIs, and that's the building, the logic, and connections. Next, we have the databases, which manage and store all user information or recommend exercises displayed by the user. And this makes every individual user's experience special through their own customization. So to start off, I started my design process using Figma. I created a prototype to map out how the app should flow, and this helped me think of the user's perspective, especially since many arthritis patients tend to be older and may not be as familiar with technology. That meant by design, I had to focus on simplicity with large buttons and clear navigation so the app could be usable for everyone. I chose React Native for the front end because it allowed me to build an app for both iOS and Android phones using tools like Expo. And along the way, I improved my skills in JavaScript, which is a programming language that powers much of the web, and TypeScript, which is programming language built on top of JavaScript that adds more structure and makes code easier to manage. Both were very vital in structuring my app. Next, we have the API/backend. And for the backend of things, I worked with Nest.js, and that's a framework for building APIs. And this is where the brains of the app live, handling requests, connecting different parts of the system, and making sure everything runs smoothly. Lastly, we have SQL, which stands for Structured Query Language. And I use these databases to store important information like pain logs, exercise recommendations, and vitals from a glove coming up later in the slides about the future. And I use Postman to test my APIs and make sure the data was flowing correctly. Through the hands-on learning process of developing this app, I have gained a solid understanding of how front-end, back-end, and databases all connect in app development. But working on our Track app is only the beginning. And outside my work with Polygence, I've begun developing this piece of hardware called NeuroScan. And NeuroScan is a smart glove that can track grip strength, range of motion, skin plaque, and heart rate monitoring, sending the data to the app in real time. And once I integrate NeuroScan with the R3 app, R3 can recommend personalized exercises and even predict flare-ups. Pictured here is a prototype of the glove. There are three sensors that will be implemented, including an Arduino switch on top of the glove to show recommended exercises and necessary vitals. For the three sensors, they're one, pressure sensors on the fingertips to track grip strength, two, infrared sensors to track plaque in the joints, and lastly, the heart rate sensor to monitor heart rate. This project started with a simple goal, to somehow help my grandma manage her arthritis. But along the way, I realized it could help millions of people like her around the world. And my ultimate vision for this project is to create an accessible, multilingual app that gives those who struggle with arthritis a recipe for success. Thank you.